Hello friends, my name is Sadiq Khan. I work with Open Minds. Here at Open Minds, we work consistently on innovative methods of learning and teaching. Today, I would introduce you to a new concept of learning, that is through video classes. However, this concept is not new for Western countries, but still in India, we're new with this. Now, one question people have in mind when I talk about these video classes is it really possible to learn any subject through videos alone? Well, some students cannot really learn in the classroom environment also. Now, is it really possible? Let's check it out. So far we understood that video classes are more convenient than the regular classrooms in terms of that you can repeat the classes as many times you want, especially during examinations when you don't have any teachers available simply because all the portions have been done by that time. Then is when you need a teacher. Then you have video classes, we can play them back again. And the last thing is you can actually study whenever you want to study, right? Fine. One thing I want you to keep in mind is that, see, in classrooms you have a teacher who can watch you, right? If you're losing your concentration, a teacher would put you back because he's watching you. Now, in this virtual classroom where I'm teaching you, there is no one to watch you, so you got to watch yourself, all right? So now, all these things apart, we know that video classes are convenient, but is it really possible that we can understand the subject? Fine. For this reason, I'm taking this demo class. So I'm choosing one of the difficult chapters of your second PUC, that is differentiation. If you can learn differentiation through this video, a demo class what I'm taking now, you can actually learn the rest of the syllabus very easily. Before I start, let me tell you that formulas are the power of solving problems. Some students do have a habit of writing formulas in a sheet of paper. They refer to the sheet of paper and then solve the problems, which is actually a very wrong way of solving problems. In fact, I can say that formulas are the ability to connect between two stages or steps of a problem. They are the ability of thinking in solving problems. Now, I have a couple of formulas listed from differentiation. In fact, I can say they are enough formulas to learn differentiation. Any new formulas required, I will write them down in a little later. If you guys are good at these formulas, fine. Otherwise, I want you to stop this video, write them down in a sheet of paper and by heart them. Trust me, it is very important that you have to know them by heart. Alright, let's do this activity and continue. I assume that you guys now know these formulas, but I want to tell one trick to remember the trigonometric functions. Here, a couple of them have a negative sign. Right? Now, which are the functions which will carry a negative sign on the right hand side? You can see all the functions which start with C, the letter C, cos, cosecant and cot will have a negative sign on the right hand side. Does it apply to the inverse trigonometric functions also? Yes, it is. Look at this. Cos inverse of x got a negative sign. Similarly, cot inverse of x and cosecant inverse of x have a negative sign on the right hand side. What about the hyperbolic functions? It is a little different. I can see that the first three functions, that is sine hyperbolic x, cos hyperbolic of x and tan hx, that is these three guys have a positive sign, and the last three, that is secant hx, cosecant hx and cot hx have a negative sign. That is it. Now we are good to start differentiation. Okay? Differentiation is a very simple topic, and let me tell you that it accounts for almost 50 marks in the final examination. What is that you have to know to learn differentiation? Simple. A couple of formulas and some rules. I'll teach you all these rules. Now let's start with the first function you have. Y is equal to x power n. Here, the first rule I say is you can only differentiate a function which looks like x power n only. If it doesn't look like that, make it look like that. That's the first rule. Remember that. Let's go ahead and do these problems to understand this. I have x to the power 6, y is equal to x to the power 6. How do I differentiate this? dy by dx is equal to 6 into x to the power 6 minus 1, that is 6 into x to the power 5. It just looks like this, right? If I differentiate this, dy by dx is what? Whatever n is here, I come here, the x to the power n minus 1. Same here, right? Let's go to the next problem. It says y is equal to x to the power minus 5. Now, n is a negative number, not an issue. Now, dy by dx is what again? It simply says minus 5 to the x to the power minus 5 minus 1, which is minus 5 into x to the power minus 6. Simple as that. Go with the next one. Again, I have what? I have x to the power half. Right? Now it is a fraction. It's not a problem again. N can be a fraction. So what is dy by dx? It is simply like half into x to the power half minus 1. That is it. That can be half into x to the power, if you simplify this, minus half. That's it. Now comes the problem. I can see that if at all I have to differentiate y is equal to 1 by x to the power 3. Now this guy doesn't look like this, right? Simply because x in the denominator. So first thing is to put it up. dy by dx goes like what? X to the power minus 3. Now does it look like this? Exactly. Now differentiate it. It goes like minus 3 into x to the power minus 3 minus 1. Simple. Minus 3 into x to the power minus 4. Isn't it? Now, let's go to the next question. It says y is equal to 1 by x to the power minus 4. Again, it doesn't look like my question. That it has to be. Make it look like this. Put x power minus 4 up. It becomes x power plus 4. Can I differentiate this? That becomes easy again. dy by dx is 4 into x power 4 minus 1. That is 4 into x cubed. That's it. What's over the next question? Let me erase this. The next question says y is equal to root of x. Now, this guy definitely doesn't look like this, right? Now, what should I do? I should convert this guy in terms of index form. It goes like y is power half. Now, this can be differentiated because it looks like y is equal to x power n. Again, the same formula, half into x power half minus 1. That is it. Let's go with the next question. I have it here as y is equal to cube root of x squared. Does it look like this? No. So how do I convert this into the form? Again, use the index form. It is x squared to the power 1 by 3. It can be around x to the power 2 by 3. Now can I differentiate this? Exactly. dy by dx goes like what? 2 by 3 into x to the power 2 by 3 minus 1. That is it. Try to understand any function which does not look like y is equal to x power n, you cannot differentiate. If it does not look like that, make it look like that. That's the first rule. Get that straight. Now let's take another problem here. I have something like y is equal to 1 by root of x. Again, this cannot be differentiated. It doesn't look like this. First of all, it is there in the denominator. Can I put it up? Let's check it out. I can write this guy as x to the power half. Now put it up. It goes like x to the power minus half. Does it look like the form? Yes, it does. Now I can differentiate. dy by dx would be what? It would be minus half into x to the power minus half minus 1. Very simple. Simplify this. It will be minus half into x to the power minus 3 by 2. Again, the next question there. What if you have y is equal to 2 into x to the power 6? Now, this number is extra, right? I would not differentiate this. I'll just keep it outside and differentiate x to the power 6. That is very simple. Now, how will I differentiate this? dy by dx would be what? Just keep 2 outside. Now differentiate this regularly. That is 6 into x power 6 minus 1. Or I can directly do this using a shortcut. It says what? Simply, if y is equal to 2 into x power 6 is there, I multiply these two numbers. That is 12 into x to the power right side 6 minus 1 again. That is 12 into x to the power 5. That's how simple it is. Now, come to the 9th problem. This guy's a little interesting. Here I have y is equal to x cubed to the power root of x. Now there are two x terms here, right? I cannot differentiate this. Remember, it should be only one term and it should be in the numerator. Now there are two x terms. So what can I do here? Make it one term. I can write this guy as x to the power half. Now the next step is put it up. Use indices, laws of indices. I can put it up. It goes like x to the power 3 minus half. Right? That becomes x to the power 2.5, or I can also say x to the power 5 by 2. Right? Now, can I differentiate this now? Yes. This guy looks exactly like this. X power n or x power 5 by 2. How will I differentiate this? It's simply like dy by dx would be equal to 5 by 2 into x to the power 5 by 2 minus 1. That is it. Now we understand this. The one rule you should know to differentiate the first function, that is x power n, is simply anything which looks like x power n can be differentiated. It does not look like that, make it look like that. Very simple rule. I hope you understand this. Alright guys, now let's move ahead. The next rule of differentiation is very simple. We can differentiate one function at a time. Alright, that's it. Now let me connect it to a simple example. Let us say that we play a game, and the rule of the game is we can fight one person at a time. What if there are more people coming together? Let's say these two guys coming together. Now I'm talking about functions now. Two functions coming together. There can be three ways they can come. Right? One is there's a plus sign between, and it can be a multiplication sign and a division sign. Right? I say that if at all they're coming like this, all right, one by one, I can still differentiate directly just using these formulas. Let's go with the first guy. Anyway, this guy says what? Differentiation of sin x is what? dy by dx is simply cos of x. Nothing much, right? If there are two functions and there's a plus sign or a minus sign, I take them as one by one only and differentiate like what? Like dy by dx says differentiation of tan x is what? Simple secant square x, and differentiation of e power x is e power x itself. Very simple. Now, the third guy. Here again, they're coming one after the other. The first function is what? Sine inverse of x. Differentiation is what? It would be 1 by square of 1 minus x squared. Since there's a minus, I write a minus. And what's the differentiation of log x? Is 1 by x. It's a minus sign here. Alright. What about this guy? 1 by sin x. Can I differentiate this? Now look at this. Here I don't have any formula which is there in the denominator. So what is the point? I should first put sin x in the numerator and just check whether this belongs to the formula list. Right? Now what is 1 by sin x? I know it is cosecant x. Now can I differentiate cosecant x? Yes, I can. It goes like this. dy by dx of cosecant x is minus cosecant x into cot x. This is one of the formula here. Right? Now the last guy is again saying like what? It says 1 by tan x. Can I differentiate 1 by tan x? No, I cannot. Again, I have to put tan x in the numerator first. So it goes like, I can write as cot of x. Can I differentiate this? Yes. dy by dx would be what? It will be minus cosecant square x. Now very simple. So now we understand the rule. The rule says I can differentiate one function at a time, and we can add on with the rule that I cannot differentiate any function in the denominator. First I got to put them up. That is it. Now let's see how I differentiate two functions which are coming together like this. Alright? Same rule follows. The rule says I can belt or I can fight one person at a time. If two guys are coming like this, what to do? Simple rule. Let's say I hold the first guy. I'm not fighting it. Okay? Keep the first guy and belt the second guy. That is it. Log of x. And now I add a plus sign. Again, keep the second guy and belt the first guy. Very simple game, right? Two people coming up, hold the first guy, belt the second guy. See, hold the first guy, belt the second guy, second, hold the second guy and belt the first guy. Very simple. Now what's the answer here? It is sine of x into differentiation of log x is 1 by x plus log x. I don't do anything. See, there is no differentiation sign for these two guys, so I don't differentiate here. That is it. Now, what is the differentiation of sine x? It says cos of x. That is it. Here again I have what? There are two functions, all right? They're coming together. There's a multiplication sign. So there's a first guy and the second guy. Keep the first guy and belt the second guy. Plus, keep the second guy and belt the first guy. How simple is the rule? All right? So again, we're following the same thing. We're belting only one guy. We're fighting one person only. If they come together, keep one guy aside and fight the other guy. Very simple. Let's say e power x into 1 by root of 1 minus x squared plus sine inverse of x into e power x. That's the answer. We'll see how to work with this. It's a quotient rule. Let me just clean the board. Alright. Let's go with this function where I can see that there are two functions, one about the other. That is sine x by x squared. So how do we differentiate this? It says y is equal to sine x divided by x squared. Now, there's a little different way of differentiating this. Alright. Now let's say dy by dx. In this case, when two guys come together, I need to find them. I keep the denominator first up here and differentiate the numerator guy. That's it. Alright? Rule of the game, right? Now, minus. I take a minus sign and I keep the numerator now here and differentiate the denominator. That is it. And the whole divided by the denominator whole squared. That is it. Okay? Now see, where all I find the differentiation sign, differentiate using the same formulas. It goes like this, x squared into differentiation of sine x is what? I have as cos x. Alright? Minus sine x. How will I differentiate x squared? That is 2x and x to the power 4. That is it. Very simple. So we understand however we get two functions, whether you have a plus sign, a multiplication sign or a division sign, we can differentiate them using the same rule that we can fight one person at a time. That is it. Let us compare all these three together now and try to understand them better. Okay? Alright. Before I go ahead, let me tell you that learn the formulas by heart, without which differentiation is pretty difficult to understand. Okay? Now let us practice the fighting rule. The fighting rule where two guys can come in three different fashions. Let's say there is two functions now in this case. That two functions come with a plus sign in between, a multiplication sign and a different sign. Alright? The rule is simple. The fighting rule. You can fight one person at a time. Here what happens? Here the rule says y is equal to u plus v. Okay? These are the two functions. I'm writing the standard formula. Here, if I have to differentiate dy by dx, it goes like differentiate d by dx of u plus v. That is, I differentiate du by dx alone plus dv by dx again. That is it. Very simple rule. Here in this case I have what? As y is equal to differentiation. Let's say dy by dx is d by dx of u into v. Okay? And that is the rule. In your bookish language I'm talking about. Now here in this case I do what? I keep the first guy and differentiate second guy plus I keep the second guy and differentiate the first guy. Very simple. Here in this case, I have y is equal to u by v. Alright? They're one about the other. In this case, if I have to differentiate d by dx of y, it goes like d by dx of u by v. How do I write this? I take v, the denominator function, differentiate the numerator guy minus, that is u, minus keep u here and differentiate the denominator divided by denominator squared. Very simple. Let us work the same problem with this. Here in this case, I differentiate directly. So dy by dx would be what? d by dx of sine x plus d by dx of log of x. That is cos x plus 1 by x. Right? Remember, I'm differentiating one function at a time. That's it. Here also what's happening? I can see that u, who is u, that is sine of x, into differentiation of what is v? V is the second function, log of x, plus v is the second function, that is log of x, into differentiation of the first function, that is sine of x. That is it. Here also I'm differentiating one function at a time. Alright? That is, I'm finding one person at a time. That's it. That is sine of x into 1 by x. Here is the differentiation. Plus log x I'm not touching. This guy is aside. Differentiate this as cos of x. Done. What about the last guy? Here. Here in this case v is the denominator, that is log of x, and differentiate who? The numerator, that is sine of x. See, I'm differentiating one function at a time. Keep that in mind. U is again sine of x. I have to differentiate denominator, that is log of x. The whole thing divided by log of x whole squared. Now what happens here? Log of x. How do you differentiate sine x? This is my standard formula. Very simple. That is cos x minus sine of x into differential log x is 1 by x divided by log of x whole square. So how simple is the rule? The rule is very simple, that I have to differentiate one function at a time. Now these guys can come in three different fashions. I have three different ways of differentiating, but I differentiate one function at a time. That's all about it. Let's learn chain rule after this. Okay, let's talk about chain rule now. Chain rule is one of the most confusing rules in differentiation. Anyway, if you know what is chain rule, I can say that you know 50% of differentiation already. Alright, now I can only say that you can learn better and better differentiation only by doing a lot of problems. Now, I can suggest you one thing, that take a demo DV of mine in which I've done more than 150 problems on differentiation alone, which can teach you different levels of differentiation. For now, let us continue with chain rule and see how exactly we can connect it to another story. Since it is confusing, let me connect it to a simple story. Again, we'll play a game. The game is different now. It says we got to find the princess. Okay, in this game we are trying to find the princess, and let's say the princess is x, and these are the walls. Okay, these are the walls. Let's say this is a fort and there's a princess and you're the prince and you're trying to save the princess. What is the first thing you have to do in the game? You got to first break the outer wall and the next wall and the next wall, and finally you reach the princess. Let me connect this to a problem of chain rule. Let's say you have a function like y is equal to sine of log of e power x. I can see there are three chains. The first is sine, and the next is log, and the next is e, and then you find x. Alright, now how do I break the chains? Who's the outermost wall? First you got to finish or break the outermost wall. That's the rule. So how do I differentiate sine? I know differentiation of sine x is cos x, so I write differentiation of sine x. Let's say dy by dx. Differentiation of sine only is cos. And what is inside sine? Write everything here. Remember this. This is what is confusing. I only differentiate sine as cos. Don't think about x. What all is inside, just write that. Okay. What is the next job to do? Today's job is done. Let's say I finished the first wall. What about the next thing? The next wall. Who's the next wall? Is log. So I'll say I will differentiate this in the next step. Okay. In the next step, what happens now? I'll write this the same way. There is log of e power x into. Now I'm differentiating log. How do you differentiate log x? Differentiation of log x, if you remember, differentiation of log x is what? Is 1 by x. Now in this case, I have log of e power x. I have only log. I should not see x part here. Here there is a x, but here is a e power x. So what I do is I just differentiate log as what? 1 by what all is inside log, that is e power x. That's it. That's how I differentiate log alone. Alright. Now what is left out? Left out is e power x. Now this I differentiate in the next step. See, I broke two walls. The last wall is left out. Then I can reach my princess. Alright, let's go ahead. That is cos of x, cos of log of e power x is the first wall, 1 by e power x is the second wall, and the last wall is e power x. Differentiation of e power x is e power x itself. So e power x. That's how simple it is. Okay, let's do a couple of more problems to understand chain rule better. Okay. Alright guys, before I can do difficult problems in the chain rule, you should know how to do problems in chain rule using these functions. Alright, let's take the first function and understand what exactly it is. Let's say y is equal to e power x. How do I differentiate this? I know the simple formula is dy by dx is e power x itself. That's it. Is that so? No, there's something else. If I have to differentiate y is equal to e power x, actually I differentiate like dy by dx is equal to e power x into differentiation of what is there on the head of e, that is x. Now that becomes e power x into dx by dx. But I don't write this. Simply why? Because it cancels up to give you 1. So answer is e power x itself. Now let us write it in a little more different form. Y is equal to e power x. I can write this as, or let's say y is equal to some function. Alright? Differentiation of this. So dy by dx would be what? The same function into differentiation of whatever function was there inside. See, I'm just connecting. e power x is e power x itself. The same question comes here. Again, I differentiate what is in the head of e. That is it. Alright. Now let's say another problem here. Y is equal to e to the power sine x. Alright. Now how do I differentiate this? dy by dx would be what? E to the power sine x into d by dx of sine x. That's all about it. Okay, in the next step, since I can differentiate sine x still, I have to go to the next step. It says e power sine x into cos of x is my answer. E power sine x into cos of x is my answer. That is dy by dx. Now see, the same thing is happening here. I don't write this. Simply why? Because dx by dx become 1. And this is the general format I want you guys to remember. Whenever you have e power x functions, you have to use this. Let's take another problem here. Let's say I have y is equal to e to the power, this time let's say log x. Alright, so how does it work? dy by dx is what? Simply write the same function, that is e power log x, into what is in the head of e, that is d by dx of log of x. That is in the next step, e power log x into differential log x is 1 by x, and that's my answer. Right, I hope you understand this. I'll try to do more problems into this. Let's take the second function after I clean the board. Let's take the second function here. It is root of x. Okay, now let's say y is equal to root of x. How will I differentiate this? dy by dx would be equal to 1 by 2 root of x into dx by dx. Okay, or differentiation of x. Whatever is inside the root, I would write here, and I would also differentiate that. That's a more general form. Why don't I write this again? Because it cancels up to give you 1. That is 1 by 2 root of x. Now, if I write it in a little different way, I can write as y is equal to root of, let's say, some function. I can write this like what? dy by dx. The format is 1 by 2 root of whatever the function is into differentiation of what was inside. That is it. So try to remember, this is a more general form. Whenever you have a root, you have to do this. If you have only x, you write dx by dx, which actually cancels to give you 1, so we don't write that. If anything else is there, you have to follow this. Let's take an example here. Let's say y is equal to root of sine x. Now what is the next thing? 1 by 2 root, instead of x, we have a sine x, so we'll write sine x into d by dx of sine x. Correct? So see the general form here. 1 by 2 root is a standard form. Whatever function comes here. Again differentiate this. That's it. So 1 by 2 root of sine of x into differentiation of sine x is cos x. Very simple. Let's do another problem. Let's say y is equal to a root of, let's this time say log x. It is again what? 1 by 2 root of log of x into d by dx of log of x. Is it the same format? Yes. See inside now, this bracket contains log. So that is it. So 1 by 2 root of log x into 1 by x. Okay, now I hope you understand how exactly I can differentiate the second function. This is called as chain rule using the second simple function. These are the things which will build up the difficult problems into differentiation into chain rule. So let's go with the third question here, that is log of x, and how to deal with this guy. The next function here is y is equal to sine of x, or I can say any trigonometric function. Let's take sine of x only. If I differentiate this, I'll get what? dy by dx is what? Cos of x into d by dx of what was inside, that is x. Okay, let's say take the general form now. So y is equal to sine of x. Instead of x, let me take any function. So what happens here? dy by dx would be what? Cos of whatever function into differentiation of the function which was inside. So remember that if I'm differentiating sine, I'm getting cos, nothing much. If there is a x, I'll write a x, and again I differentiate x. Now what happens here is dx and dx is 1, or differentiation of x is 1, so it becomes cos of x only. In this case, it is not like that. It's more general form. Now let's take a problem, try to understand. Y is equal to sine of, let's say inside is log of x, correct? It is not sine x, it is sine of log of x. Okay, so it goes like, if I differentiate sine, it goes cos into what all is inside, into differentiation of log x, and this is what I have. So that is dy by dx. Now see the next step, cos of log x into differentiation of log x is 1 by x. Okay, that's how it is. Okay, try to understand this. Any trigonometric function, for example, let's say y is equal to tan of x. What is the differentiation? dy by dx would be secant square x into d by dx of x, which I don't write simply because differentiation of x would become 1. So if I take another problem here with tan, y is equal to tan of, let's take e to the power x. Now how does it work? It says differentiation of tan is what? Secant squared. Now what is inside tan is e power x. That's it. And differentiation of e power x. The next step, secant squared e power x into e power x. That's my answer. Okay, very simple. Now let's go with the last function and see how to work with inverse trigonometric functions and how easy it can be and how easy differentiation would become after this. The last function is about inverse trigonometric functions. I'm taking tan inverse of x. Let's take it. Say y is equal to tan inverse of x. Now how will I differentiate this guy? So dy by dx would be what? It would be 1 by 1 plus x squared. Very simple. Why is it 1 by 1 plus x squared? Because there's an x here. What exactly is the general format? Let's say, in fact, I can write d by dx of x. Why? Simply because x is here. Now, if at all I write y is equal to tan inverse of some function. So what it can become? It becomes dy by dx would be written as 1 by 1 plus whatever function whole squared into d by dx of that particular function. Okay, that's a more general form. Let's take an example. Y is equal to tan inverse of, let us take log x again. What happens here? So 1 by 1 plus, don't write x squared, that becomes wrong. Okay, that becomes wrong. So what I have to write is this. What all function is here, write this, log of x whole squared into d by dx of, I can write log x. That is it. Now see what happens here. 1 by 1 plus log of x whole squared into 1 by x. That's how it goes. So whatever is here inside, you have to put in the general form. So for tan, this is the general form. So let's talk about sine inverse of x and see what happens. So if y is equal to sine inverse of x, what is dy by dx? We know the formula, it is 1 by square root of 1 minus x squared. That is it. Now what if x is not there, some other function is there? See, let's suppose y is equal to sine inverse of, let's say, tan x this time. Alright, so how it works? It says 1 by root of 1 minus, instead of x, I have a tan, so I'll write tan x whole squared into d by dx of tan x. So in the next step, I can write the answer here. It is 1 by square root of 1 minus tan of x whole squared into secant squared x. Alright, so this is what exactly you should learn. I hope you understand this. Now I'll connect more bigger problems or difficult problems using all of them. Alright, so let us just write the general formulas here once again and try to remember them. Okay, I'm very sure that you guys are more comfortable with these functions right now. Let's talk about more difficult problems in the chain rule. Alright, now these questions would be a combination of 2 of these functions or 3 of these functions. Look at the problem on the board. Here I have y is equal to log of tan inverse of x. Now, one major doubt students have is it a product rule or a chain rule? How to differentiate between these two things? Now look at this board. Here, if my question was log of x into tan inverse of x, now try to understand this. Tan inverse root x. Here, in this case, I don't have 2 different x's. I have only one x. Here I have one x here and another x here. So this becomes product rule because there are 2 functions here and multiply together. This is only chain rule because there is only one x. Alright, that's the way you identify whether you have to use product rule or you have to only use chain rule. Let's do both the problems and check what is the difference. In this case, I have to open log. How does log open? We saw the general format. Log opens like this. If it is y is equal to log of x, it just goes like what? 1 by whatever function you have inside log into differentiation of this. So in this case, dy by dx would be what? What is inside log? This whole thing. So just 1 by whatever is inside, just write off. Into differentiate what was inside. That is tan inverse of root x. Nothing much. Okay, the next step. There is no differentiation sign here, so don't do anything. But here there is a differentiation sign. So what should I do? In the next step, tan inverse of root x into, how will I differentiate this? Again, let me go back to tan inverse. Okay, this is a general format here, right? Now in this case, I can see that whatever is inside would come here with a square. And this is a format, 1 by 1 plus whatever function whole squared. So it goes like 1 by 1 plus whatever function, that is root x now, root x whole squared, into d by dx of root x. That's how it goes. Now the next step, I have 1 by tan inverse of root x. I can say this is 1 by 1 plus, I can cancel these 2 things, that is x, into differentiation of root x is 1 by 2 root x. We know this. Very simple. That's my answer. Now let's say how to differentiate the second function here. Here we identify this as the product rule, that is u into v. We know how to differentiate product rule, right? Simple. I keep the first function, that is log of x, and differentiate the second function, that is tan inverse of root x, plus I keep the second function now and differentiate the first function, that is d by dx of log of x. Nothing much. Now let's see what to do. There's no differentiation sign, just write off log x into differentiate tan inverse of root x. Again, come back to this. Tan inverse of whatever function goes like what? 1 by 1 plus whatever function whole squared into differentiation of that function. In this case, what do you have here? Is root x. So I'll just follow the format. That is 1 by 1 plus root of x whole squared into d by dx of root x. And that's how it goes. Plus tan inverse of x, I'm not differentiating, no sign here, but I'm going to differentiate log x, that is 1 by x, and that's it. Nothing much. I hope you're getting this. Let's go ahead with this. Now the last part of it is log of x into 1 by 1 plus, I can cancel this root and square, I get x. How do you differentiate root x? 1 by 2 root x plus tan inverse of x by x. That is a simple difference. Try to understand the difference between only chain rule and product rule is this only, that if at all there's only one x, alright, that becomes chain rule. If there are one x and another x, there are 2 x's, it means 2 functions with a multiplication sign in between. That's how we identify. If there are 2 x's, it has to be product rule. There's only one x, it is only chain rule. I hope you got this. Let's do the second problem here. Let's try to do the second problem on the board here. It says y is equal to sine of tan inverse of x. Now again, let us try to identify whether it is product rule or chain rule. So what was the deal? If at all there is only one x, then it is only chain rule. If my question was y is equal to sine of x into tan inverse of x, I can see that there are 2 x's here, 1 x here, 1 x here. This becomes u and this becomes v. So that is product rule. Now let's go with this guy. Now here, dy by dx. Again, if I have sine, what is the general format here? If it is y is equal to sine of whatever function, it goes like dy by dx is cos of the same function into differentiation of that function. If it is only like, let's say it was only like y is equal to sine of x, then differentiation will be what? It is cos of x. If there is x alone and dx by dx or d by dx of the function, which is x. Now, since there is not x here, there is tan inverse of x. Now, what should I do? We have to write it in the general format what we have here, right? So that goes like cos of tan inverse of x into d by dx of whatever the function is, and that is tan inverse of x. I hope you're trying to understand what's happening here. Let's finish this problem. Cos of tan inverse of x into, how do I differentiate tan inverse of x? It is 1 by 1 plus x squared. Simple. This is a formula. This is a simple differentiation formula we have. Now let's try doing more difficult problems into chain rule. We could understand the single chain, that is the general formats. We also did problems involving two chains. Alright, now let's see this problem. It says sine of log of tan inverse of x. Okay, there are three chains here. Now let's go with a check whether this is product rule or chain rule. I can see there's only one x. If there is only one x, I simply understand it is purely chain rule only. Alright, now let's go with this. Y is equal to sine of the first chain, log of the second chain, and tan inverse of x. Now this is what we have. Now if at all my question was y is equal to sine of x, I differentiate this like what? dy by dx would be cos of x into d by dx of x, which becomes 1. Cos of x is the answer, right? If not x here, is something else inside sine, so I should go with the format. What is the format? If sine of whatever function, it goes like cos of that function into differentiation of the function. Now let's go with this. Okay, now here I have sine, so it opens like cos of whatever the function inside, write off log of tan inverse of x into differentiation of, now what is the function here? Write that function, that is log of tan inverse of x. That is it. Okay, now what is the next step? I can see that cos of, I don't touch this because there is no differentiation sign here. There is differentiation sign, for we have got to work on this, not on this. Just write this down, log of tan inverse of x. I broke the first chain. Here again I have what? Log of tan inverse of x. How do I open log chain? Here this guy. Log of whatever function goes like 1 by that function into differentiation of that function. So it goes like 1 by what is inside log? Tan inverse of x, correct, into d by dx of tan inverse of x. I hope you're getting this. There are three chains. We broke the first chain here. Now we broke the second chain here. Now what is inside is the third chain. See how to work with this guy. There is no differentiation sign here. I can write cos of log tan inverse of x into 1 by tan inverse of x. Here, now let me differentiate tan inverse of x as what? 1 by 1 plus x squared. We know the formula. Now there is a single x. I can write d by dx of x. That becomes 1, so I don't write that. So that's how simple it is. Whatever big the chain is, now we can understand this. If you have these general formats and you know how to differentiate each particular function here, it is very easy to do problems into chain rule. I hope you understand what is chain rule now. Now let's see how to work this problem on the board. This problem involves both chain rule and product rule. How to identify this now? Let's go with the problem. Here I can see that it is root of sine of cos of x. So I can find 1x and again into log of e power x. There are two x's. It means there are two different functions. So there is product rule here. So I can say this is one function and this is another function. So first let us use product rule and open this guy. Then we'll see whether we have to use chain rule or not. Alright. Now here in this case, this is the first function. I keep it like that only. That is root of sine cos of x. I don't touch this. Into differentiation of the second function, that is log of e to the power x plus, I keep the second function just like that, that is e power x. This is simple product rule, we know this. Differentiation of root of sine of cos of x. Okay, there's only one x here. Now in this case, I don't have any differentiation sign here, so I would not differentiate this. I write it just like that, that is sine of cos of x. Now here is differentiation sign. Now again I have log of e power x. It is not only log x. Don't write this as 1 by x. Okay. If it was, let's say it was only y is equal to log of x, then dy by dx would be what? 1 by x. That is it. Okay, but this is not log of x. This is log of e power x. So I have to go to the general format here. Log of any function is 1 by the same function into differentiation of that function. So it goes like 1 by this function, that is e power x, into d by dx of e power x. Now that's how I open it. Okay, now the next thing is what? You have a plus sign, write the plus sign. There is no differentiation sign here, write it just like that. That is e power x into differentiation of root of sine of cos of x. How do I differentiate root? Come back to this. Here, root of any function is 1 by 2 root of the same function into differentiation of that. Whenever you find a root, you have to follow this thing. So I can see a root here. It goes like 1 by 2 root of whatever function, write this inside. That is sine of cos of x into differentiation of what is inside. That is sine of cos of x. That's how it works. The next step. Here I can see that this guy would not change. That is sine of cos of x into, I would write this also, 1 by e to the power x. And how do I differentiate e power x? The answer is e power x only. This is a simple formula we learned, right? Now what is the next thing? Plus log of e power x into, there is no differentiation sign here, just write it off, 2 root of sine of cos of x into differentiation of sine of cos of x. How will I differentiate sine now? I can see that this case, sine of any function is what? Cos of that function into differentiation of that same function. So again, it is not only sine x, it is sine of some function. So I can write, instead of sine, I'll write cos of whatever function, that is cos of x, into d by dx of this function inside, that is cos of x. Don't confuse here. I'm differentiating this chain, that is sine as cos, and whatever function inside, write this. Again, differentiate that function inside. So again, there is no differentiation sign except for this guy. So write the whole thing once again. That is root of sine cos of x into, I can cancel this actually, give 1 here, plus, that is log of e power x into 1 by 2 root of sine of cos of x into cos of cos x into, how do I differentiate cos x? Is minus sine of x. That's all is the problem. Alright, now here we understand if they have to give you more difficult problems, what they do is they combine more of these functions, and they also include product rule or quotient rule. And that's all it is. If you know how to break product rule, quotient rule, and these basic functions, you can actually solve differentiation very easily. I hope you got this. Let's try to do some more problems to understand this better.